Okay, I'm going to pass around sign-up list for the field trip and the term paper. They go on the same page. 3 sheets for each side. So if you would, put your name on the list under the right category, okay? This will be a longer one. That can go around to this one over here. So get out those clickers. Here you go, thank you. I know some of you are in sports or doing arts, filming, and your schedule is uncertain relative to the field trip. Just make a best guess now. If you've got a special situation, we can change it for you, okay?
What's the date?
Huh?
What's the date?
It's at the end of March.
How long is the field trip?
All day Saturday, from 9 a.m. to 9 p.m. I mean 5. Had you?
What's the date again?
Somebody look on the syllabus for me.
It's
March 31st? March 31st, Saturday. And we're going to rock. And on the syllabus is a page devoted to it about what to bring. If it's raining, we go. If it's snowing, of course we'll go. I'll pelt you with snowballs and we'll have a wonderful time. Yes? Sure, send me an email. Great. I won't remember it orally just yet. I'm actually researching it now. I'd love if you've got any good quarries or any outcrops or a beach you'd like to go walk down, tell me. We'll talk about it all. Okay, let's get the clickers out. Ah! Never mind. I did something wrong. I know what I did wrong. Silly me. I hope you weren't looking. Let me try it again. There we go. Come on in, guys. You're good. So, a bahada is a dry lake bed in the desert. A bahada. Oh, so many new terms. Dr. A, you're killing me. So let's practice. Here we go. The polls are open. Countdown is on. By the way, some of you have been writing for the links. Where are the videos? Where are the videos? Because they're in 2 different places. So I put the links on the information page of Blackboard. The information page of Blackboard has both ways. There they go. Ooh, you really split on this one. And most of you got it wrong. A bahada. What's the score? A bahada is a depositional feature created by a coalescing alluvial fans, okay, at the bases of mountains, created by flash floods. That's a bahada, all right? What's the name for a dry lake bed? I like to play baseball. Playa. That's a dry lake bed. There's also salt flats. We'll take a picture. Correct answer is false. The coastal Alta Lama Desert of Chile, one of the world's driest, has its moisture taken from the Andes. This is very specific, but this was our one example where you get a desert on a coastline created by geography, okay, like rain shadow, but it's coastal. Is this true? What do you think? I will now open the polls. And there's the countdown, and you're firing away. I know you're here. Thank you. And you said, woo, true. And the correct answer is true. Way to go. That's it. That's it. All along the coast of the Andes. It's all desert there. She's taking a picture. I'll wait. We're on. You'll see these again. Here's another hard one. The flat erosion surface, I only mentioned it like twice, formed by running water at the edges of retreating desert mountains, is termed desert pavement. Look at this face. Would I lie to you? Would I try to trick you? Would I do mean things to you? Okay, the countdown. You're firing away. And you said 64. 2/3 said false. That's the correct answer. All right? The erosion surface, the flat erosion surface is called a, you are an impediment to my education. A pediment. Different words, but they sound alike, right? Pediment. A desert pavement is that flat surface created by wind erosion. When the sand blows away, the ground lowers, called deflation, and you're just left with cobbles on the surface. Very fragile surface, very easily scarred. That's a desert pavement because it looks like pavement and it's in the desert. Okay? The steep side of a sand dune or ripple mark is on the upwind side. Poles are open, the steep side, they're all asymmetrical. Is the steep side on the upwind or the downwind? And now the countdown. Doing good. Hurry, hurry. Fire away, fire away. 3, 2. Come on, come on. Make a stab. All right. 65% said false. That's the correct answer. All right. The steep side. I'm tricking you along today. So if you're in that 1/3, all right, that's okay. This is safe, not for a grade, all right? You're participating, that's what we want. It goes, the sand dune erodes on the gentle side, advancing, and then the sand, after it's blown over, comes down that lee slope, all right? The steep side, called a lee slope. And that's the depositional surface, which eventually forms inclined beds in a sedimentary layer called cross beds. So you can look at a cross bed, those are all the down slopes. You can look at a cross bed, and those downward slopes is the direction of wind movement, even after the sand dune is gone. Okay? All right, here we go. Subtropical deserts occur along the equator. Is that true or false? Subtropical deserts occur along equatorial latitudes. All right, the polls are open. Countdown is on. Here we go. Real exam questions. The class you just had. How well did you learn? How well did I teach? Okay, here we go. And you said 51. That's 51 versus 49. Excuse me. Oh. The equators don't have deserts. That's where all the rain is, right? The air gets warmed, it rises, it rains, it rains, it rains. But then the air rises, losing its rain, and comes down to the tropics. 25 degrees north and south. And it's already lost its water, and then it warms as it gets closer. It's doubly warm, okay? A lot of double warming. Okay, first we're losing its water, and then warm it, hot air. I can dry that hair with a cold hair dryer or a hot hair dryer. What's he doing to me? I got that on camera? Desert regions of Earth are increasing in size today. What do you think? Fire away. All good, good. Are you getting the green light when you click, click, click? All right, countdown is there. Come on, get over, go, go, go. All right, 91% said true, and that is the correct answer. 9% of you thought otherwise. But now you know. Rain shadow deserts, I don't know how to get it to drop down, forms on the downwind from mountains. Rain shadow desert forms downwind from mountains. Rain shadow. That should be a song, what you think? Okay, there's the countdown. Here we are. 6 seconds left. Get it done. All right, 2, 1. Very good. This is how I know you're here. 83% said true. Aha. That's the correct answer. All right. Well, there you have it. Take a picture. Okay. Quit. I don't need to save the PowerPoint. But I do save the session date. Where's she going? It's on camera. Well, there it is. So, I am so dedicated to saving your life, I decided to take an entire lecture and just talk about ozone. Now, you've learned about ozone at ground level, created as part of smog, it's air pollution, ozone at ground level, O3, very reactive oxygen, needs sunlight to form. It is photochemical in origin, right? So we've learned about that. But high up in the atmosphere, where our air is thin, there's a new kind of ozone that's good for us. And it's saving the Earth. The Earth has so many ways it's saving us. Its ozone layer, up higher than the airlines fly, over 50,000 feet high. Airlines like to be around 34. Way up there. If you get out of your spacesuit up there, you're going to be irradiated with 100% ultraviolet radiation. And the sun is blasting us with all kinds of radiation. And we have this wonderful atmosphere. We've learned about our greenhouse gases, which are growing too fast now, that keeps us very warm at night. Without those greenhouse gases, we'd be freezing. Pull me off the blanket, please. So we know about our greenhouse gases in our atmosphere. We've also learned about our magnetosphere. Our Earth is magnetized and it's repulsing all the gamma rays and the plasma particles coming out of the sun. And then also coming out of the sun is a whole range of other wavelengths. Infrared, visible, we like it, I see you. And then black light, short wavelengths we call ultraviolet. We go from the electromagnetic spectrum from red to green to blue to violet. We're getting shorter wavelengths. And then we go into blackness. You can't see it. And black light is a very energetic wavelength. And there's a range of wavelengths in them. Now, the longer wavelengths of ultraviolet, really close to violet, are very good for plants. They're not really too damaging unless you get a lot of it. Plants thrive on it. Some of you have heard of black lights, right? Where you could grow plants, legal and illegal, in your closet. Yeah, and we put a little purple violet in there so you can see that it's on. All right, and the rest of it you can't see. That stuff's not bad for you. The plants love it. All right. And then you get into the shorter parts of ultraviolet radiation, the middle and the shortest. And that real black radiation breaks down your cells. It breaks down your DNA. It breaks down your immune system. All right? So the entire food chain of the planet breaking down because of this ultraviolet radiation. It used to be that ultraviolet radiation got entirely absorbed, except for 1%, by our ozone layer. But now our ozone layer is eating away. And not just at the hole. So I'm going to show you the whole Earth. The ozone layer is thinning away. So you're going to see today, it's no longer cool to get a suntan. How many of you suntan? Come on, show me. How many of you do it unprotected? I'm talking about suntanning. Oh, no. See, I'm here. This is why we're here. This is why we're having this class. Oh, God. So, our wonderful atmosphere, from now on, you will do it. Protect it, okay? I know you'll do it. Protect it. So our wonderful atmosphere, it gives us water, it gives us air. The greenhouse gases are there. It has bad ozone at the bottom we talked about. But now let's get up above. In our upper part of our atmosphere, where the good ozone is, it forms in a very similar way, but it's dying. Oh, there's the hole. So the stratosphere, the troposphere is where we live. The stratosphere is where the airplanes fly, but the ozone layer, the upper stratosphere is where the ozone layer is, and it's absorbing the sunlight. Oh, we like it. So way up here in the stratosphere, all right, the troposphere is where we live, the stratosphere. So here we are in the troposphere. There's Mount Everest. There's the industrial pollution and ozone, bad ozone we've talked about. Here's where the airplanes fly. Okay, getting up into the stratosphere. All right, that's where the sunlight is eroded. So it's that air up there is very thin. There's not much oxygen. But now it's getting blasted with full sunlight. We've already learned, yes.
Going out of the Earth, does that damage the ozone thing, or is
What does what?
like spacecraft that passes?
No. Does a spacecraft rocket it through? No, it doesn't. Yeah, it just closes right. That's a good question. You know, what about the exhaust from the spacecraft? Now that would be interesting. The exhaust, because it's a huge amount of exhaust. So there's our stratosphere up in here. All right, getting blasted with that sunlight. All right. We know how ground level ozone forms. The smog, the pollution is photochemical. We learned yesterday that the UV light, the 1% that gets in, the 1% knocks off an oxygen off of NO2. So I got a free oxygen, and it can't stand to be alone. And it jumps onto another O2 and becomes an O3. O3 is unstable. Will break down as long as if the sunlight goes away or if the sun goes down. Needs sunlight to form. Also forms by lightning. In this case, lightning just blasts an O2 apart. You know, I got two free oxygens, and they look around and grab onto an O2 to make an O3. How many of you have smelled ozone? Yeah, you got to be in lightning areas. And at racetracks, the spark plugs on really high-test cars, where you can smell that ozone. It smells good. But the stratosphere ozone is a lot like the lightning story. It's now being hit with pure UV, knocks an O2 apart to two free oxygens, they combine to make the ozone. Okay? Ozone, again, is unstable, so as soon as the UV goes down, the sun goes down, then it breaks. So it keeps doing this. It keeps doing it. So the UV light hits, it knocks off a free oxygen. The free oxygen says, I got to grab somebody, and they grab an ozone. And that absorbs the UV light. That's how it works. The sunlight goes in, it takes an O2, makes an O3, frees up an oxygen, and that uses up the UV light. And so UV comes in, it's making O2 into O3, O3 breaks down, it keeps going, I'm absorbing, I'm making, I'm breaking down, I'm making. Ecology is the study of balance of cells. It uses it up, all right? That's absorbing that's how our filter works. Until we put chemicals up there that started eating the ozone. Already we know the ozone doesn't last long, but it keeps making. And now something else is going up there that's eating the ozone, and it's broken the balance of nature. And those are chemicals. They go into two categories, CFCs and methylbromides. And I'm going to talk about both of those chemicals. We made them. All right? So what ozone does is it absorbs the longer wavelengths, a little bit of it, but they're good for plants. That's the longer, that's the black light in your basements, all right? That's UVA. It's the more damaging UVB and UVC. UVC is absolutely lethal, all right? You want to go blind? No. All right, there it is. My sweet mother, 92 years old, has macular degeneration. She can't see, can't read. And this is what is caused by this radiation. Your eyes are not protected. You can protect your body with clothes and suntan lotion, rated 50, but your eyes are open. That's why it's kind of good, really good to wear sunglasses now. This is not the same earth that I grew up in. You have inherited the earth I gave you, but it's not the same earth. When I was a kid and loved to sunbathe, we could do it unprotected. I remember the indexes on suntan lotion either being 0 or like 6. Can you imagine? Yeah. And today, it's a different sunlight coming in. And the thinning of the ozone is not just in the polar regions. You'll have your attention. Mom, it's really scary out there. So here is visible light. We go from long wavelengths red all the way to blue and now purple violet, and then the ultraviolet right in there, all right? And then even shorter wavelengths, X-rays and gamma rays. It's all coming at you. So it's dark light. It prevents plants from doing photosynthesis. It's more energetic than visible light. It destroys DNA molecules, destroys your immune system, as I've said. Absolutely race indifferent. Some of you never get sunburned because you're darker skin. UV doesn't give a damn about the color of your skin. Okay? This is not about sunburn. I'm about talking about destroying your component of your body. Okay, got it? Raised in different plants and animals alike, cooked to a distinction, so it's all there. So the first big culprit was CFCs, chlorofluorocarbons, Freon, so many uses, refrigerators, air conditioners, to clean circuits on electric boards, a tennis shoe made of rubber at the bottom, a foam rubber, styrofoam. We can make great running shoes because we want to take rubber and bubble it a little bit. And what do we use it to bubble? The foam, the styrofoam, all of it. We want to, well, air causes fires. You know, you light a match in air, right? So we invented a chemical that's inert, CFCs, the friendly chemical. It doesn't burn. It doesn't cause a fire. It's not poisonous unless you breathe all of it. Hey, get in here. Okay? The friendly chemical. And in refrigerators, you want something that gets really cold when you compress it. Now we can use any kind of gas to make a refrigerator, but you want something that's also not explosive, will not cause a fire, and it does it really good if it's really cold. And so DuPont Chemical Company invented Freon, chlorofluorocarbons, because when you squeeze it, it got really cold. When you expand it, it gets warm again. So in the inside, you can make the inside cold, and then you flush the hot air that used to be there out the back. That's the way that works. So there we go, all right? But now the CFCs are getting out into our environment. The friendly chemical does not break down as a lie, because it doesn't break down in the lower atmosphere where we live. It leaks out of our air conditioning in our cars. Have you ever had a car where suddenly the air conditioning doesn't work anymore, and they had to go put in more Freon? It leaked out. And of course, you're bubbling shoes in the factory, making your shoes. We're all wearing shoes that have rubber bottoms. It's leaking out, it's leaking out. The friendly chemical started leaking out. And then it rises and fills the earth. And when it rises up to where the UV light is getting in, up in the stratosphere, suddenly it begins to break down. And the chlorofluorocarbons release chlorine, breaking down, and the chlorine is unstable and wants an oxygen and eats the O3. Eats the O3. So the chlorine out of the chlorofluorocarbons is eroding the ozone layer. A lot of the CFCs get caught in the vortex in the polar regions, particularly the South Pole, because it's the coldest there. And they just get concentrated there, and they don't break down for 6 months out of the year. Why? So the CFCs rise into the atmosphere, but up in the polar regions, they get trapped. And why don't they break down all year? There's no sunlight. So they get super concentrated, you see? They get super concentrated during the winter of darkness. Sun comes up, and now I got sunlight 24 hours a day. Blasting all that chlorine. There's chlorine everywhere. So I can build it up for 6 months. And I do it year after year after year. So we spew out the stuff, CFCs, then start eating the O3s. There's the O3s. I'm left with O2s. The O2s don't do anything, and the UV light comes blasting through. It's not just CFCs. It's also methyl bromide. Methyl bromide is not friendly. It's a poison gas. We use it to kill termites. We use it to kill all kinds of bugs. We use it in agriculture so that the strawberries you get from the market don't have any worms on them, or slugs. Okay? Wow. Farmers go through, they cover their fields with plastic, and they push that fumigate into the fields. There we go. To fumigate the soil. Have you ever seen a house that's being treated for termites? Where they tint it, right? Don't go in there. And then they pump in that gas, and that gas is so fluid that it goes right through plaster, right through wood, right through concrete. It goes into all the cupboards. It goes into all the sheets. It goes through all your closets. It kills everything. Everything. If you forgot to get the kitty cat out, kitty cat bye-bye. And sometimes transients will not understand that and will sneak into a tinted house for cover, and they die. And then the next day they pull the tents off, and where does it go? Up in the atmosphere, okay? And then it's like that. methyl bromide then rises up, gets blasted in the UV radiation, releasing bromine, which does the same thing, eats the ozone. Okay? Eats the ozone. Yeah, Lee Williamson. So it was actually predicted back in the 70s before it started. Sherwood Rowland, we'll see him in just a minute, Mario Molina, working together at UC Irvine. They predicted this would happen. It met with considerable criticism because DuPont's making a lot of money. Everybody loves air conditioning. I remember the day when our house in South Texas got air conditioning. We had it installed. We were one of the early houses on our block to get air conditioning. I took all my buddies in. We said, get in here, get in. The house is cold inside. Really? Wow, that was so cool. I mean, already department stores like Sears had it, but individual houses. I remember when cars finally started getting air conditioning. Yes, I'm that old. I'm 149 years. Okay, so they predicted it, met considerable resistance, and Ronald Reagan, the President of the United States, ordered to cut off all funding of new research on this. Amazing. Can you imagine? Politics. He didn't take Earth Science 105. But then the hole came out in 1985.
Year 2050, we see.
And there was no way it could be laughed at.
Stable. Will crops still flourish? Will the sun's ultraviolet rays be more intense? The answers will be dependent upon the recovery of the world's depleted ozone layer, and whether or not it continues to shield the Earth from the sun's dangerous ultraviolet radiation. In the 1970s, Nobel laureate Dr. F. Sherwood Rowland discovered that the main culprits of ozone depletion were chlorofluorocarbons, or CFCs, found in aerosol sprays and coolants.
I spoke up publicly about it in June of 1974. There was a lot of resistance from the industry at that time. When the Antarctic ozone hole was identified in 1985, then the resistance fell away rather rapidly.
Since 1987, nearly 200 world leaders have joined the United States to address the very real danger of ozone depletion by ratifying a treaty called the Montreal Protocol, which bans the use of ozone.
That was the first one, Montreal.
Beyond harmful chlorofluorocarbons, other ozone-depleting substances exist within our stratosphere.
The Montreal Protocol also covers some compounds which contain bromine. These include halons, which are used for fire prevention, and then some others like methyl bromide, which are widely used for insecticides and pesticides.
The Environmental Protection Agency enforces the Montreal Protocol and supports scientists in the development of
I did not mention, it also puts out fires.
The situation is serious.
Chemicals had
Progress
good uses. We didn't
For
understand.
example, is the recycling of the refrigeration
They're
chemical Freon.
We sent it off to a Freon recycling company because it's no longer manufactured according to the Montreal Protocol.
It's only by sustaining the progress that we can ensure that our protective ozone layer heals by the year 2050.
If that.
For the Weather Channel, I'm Nick Walker.
Hey, Nick. So, you go back into the 70s and we see measured with Dobson units the amount of ozone in the upper atmosphere. It looks pretty stable. And then look at it go. This is over New Zealand. Okay, it's well away from the polar region. New Zealand, well away. All right, so in the 70s there was no ozone hole. This ridge of red is normal. That's not a hole. So everything green is normal. A little higher ozone out here, and that's a natural ridge created by the rotation of the Earth. Look at in the 90s. There it is. There it is. Wow, bigger than Antarctica. So from 81 it started growing, 86, 91. Look at 1980. It's clearly there. It wasn't there in the 70s. And also, anything normal is yellow-green. It gets down in the blues. So is the blue only in the Antarctic? Look up here. Right where you live, all right? There it is in 91. It's huge. So we go from really small in the 80s up to 91. It's clearly growing. Wow. You see the belts of other blue outside. The whole Earth is being affected, all right? And it only lasts during the summer, which is August, December. Our winter, we're going to Antarctica, so it's their summer. It needs sunlight. And then the sun goes down, and the CFCs start accumulating again. They're not being broken down anymore, and the ozone comes back. Hole goes away. Hole goes away during the winter of darkness. okay? Because it needs the chlorine to chew on. All right, so there it is. So we go from 1980, there was no ozone hole, and then look at it getting bigger and bigger and bigger, up to 2005 in this one. And so it's up there, around 15 kilometers high. This is 1993 data. During the winter, the ozone layer, here we're measuring ozone in partial pressure of millipascals, just like Dobson units. So here's a plot of ozone concentration in August before the sun comes out. Still dark. The ozone will come back during the darkness of the winter time because the chlorines are not being released. Okay? And then the sun comes out, rapidly eroded away. Look at the ozone's almost gone by October 6th. Okay? So ozone winter to summer, there it is. When did it all begin? Dobson units this time, measuring the amount of ozone, pretty stable in the 60s through the 70s, and then look at it all go. What date would you say it really started eroding? Yeah, 75, 77. All right, there it is. Not going away. And here it comes down from that. Oh man, woman, phew, look at that. Wow, so by the time we got to 2000, it was the biggest ever. And we're not done yet, as you're going to see. It's not as pronounced over the North Pole, it's not as cold there. But I've explained why it's in the polar regions. So scientists went there in 1989 in the winter time, where it was dark, and they waited till sunlight came up. They waited. And within a few hours, 2 hours, they had 25 level sunscreen, and they all got first degree burns, okay? So just huge. All right, so that's why newspapers publish the UV index. It's really important, don't you see? So there's the ozone hole, and a smaller one in the north. But look at the blues all over the world, all right? And those zones are shifting and moving. You can't see the ozone thinning with your eyes, but it's there. You'll never do it unprotected again, all right? Race indifferent, doesn't matter what your skin is. Some years, the hole is smaller. Here's one where it's fairly small, 1991 compared to these other years. Wow. And then it breaks up. 2002 was a really weird one. I'll show you a movie. Watch this, 2002. Because it's sitting up there like an amoeba, and it's oscillating and fattening out. And this year, here it is, August. Now the hole's getting quite big, getting bigger. Now it's starting to get balloon. It's an amoeba. It breaks up. Look at that thing, like a huge softball. Wow, it just goes racing through the world. Blasting, you can't see it go by, but ooh, it's still the bad side, right? All right? So it is breaking up. 2001 versus 2002. Here was that famous one. 2003. I'm going to go all the way up to 2011. All right, 2005. Giant. I don't live in Patagonia. Patagonia. Rabbits have gone blind. Fish, salmon have gone blind. This is what we've done to them. They don't deserve that. All right? Breaks their eyes are unprotected. Look at 2006. Not done with it. Whoa. So the North Pole doesn't have much of one. There it is. A little bit there, a little bit there, a little bit in there. Not as much, not as dark, not as cold, I mean. Okay? But some years, 2006, it was fairly pronounced in a couple places. So it's not fitting with it. Look at all the blue down here. Fitting all over the world. So CFCs were first made in the 1920s. It was used to be making ice. Up till then, we had to go up to cold lakes during the winter and cut the ice and save it in ice boxes, big ice bars, and save it so we could use the rest of the year. We learned we could make ice. Real industry, making ice. That was the first use. Air conditioners came later. Refrigerants came later. So it was predicted in 1974. Immediately, the Environmental Protection Agency banned CFCs and aerosol cans. But it was criticized by the industry, so Reagan shut down all new funding. Whoa. Then the hole was discovered. And it was all a big lie on the other side of that wall. Okay? The hole was discovered. This is not to be confused with global warming, which in some circles seems to get still debated, but I have no reason why. But we have people like Rick Perry, and I've said global warming's a hoax. Michelle Bachmann didn't go to school very long. We didn't pay attention when they were there. But the ozone hole, once the hole was discovered, There's no effing way you can laugh this one out of the room. It's really there. And then we begin to measure it and see that it's all over the world. So people responded. We had the Montreal Accord that you heard about, pushed for 50% reduction by 1999 to Helsinki. No, let's do it faster, 100% by 2000. DuPont embarrassed, shut down making CFCs. Way to go, DuPont. Gore, as the vice president, pushed for 100% by 1996. The Copenhagen Protocol, 93 nations signed. Roland and Melina received the Nobel Prize. So cool for their work. At the same time, in my farmer state, Governor Wilson, a bill has been put forward to eliminate methyl bromide. California's a very agricultural state. He vetoed the bill. Didn't take my class either. Yes?
So, whenever you're making like styrofoam or anything like that, you're producing CFCs and bromides.
No longer. We're using safe CFCs now that will not release their chlorine in ultraviolet radiation. Good question. All right. We have shut down the bad CFCs. And people found things. We were using CFCs to clean circuit boards and transistor radios. Yes?
We've stopped production of dangerous CFCs. Is that true all over the world or just?
Yeah, because we make it for the whole world. I think I have that right. All right. Now, there may be some illegal stuff out there, black markets, I'm sure. But it's because people can make money on it. So Texas Instruments found a new way not to use it. They started saving money because they didn't have to buy it anymore. Copenhagen Protocol, our most recent. So there's the legislation. It took good laws. It took good leaders. It took people getting a good education. It's sitting in Earth Science 105. Here's the relationship between ozone and chlorine. As you go south in latitude, away from the equator, chlorine really builds because it gets concentrated during the winter, and the ozone just erodes away. So chlorine eating the ozone, and now we're up there watching. All right? This is the European satellite put up in 2006. It's got 10 instruments on there monitoring our atmosphere, watching what we're doing. The thing is that we have shut down the CFC production of the bad ones. And there's several different CFCs, bad ones. But they're up there. And the Earth's atmosphere is like a bathtub. It's full. They don't wash away. So they're going to be up there for a while. What a while. So in Queensland, Australia, that's southern Australia, like New Zealand, people in Patagonia, you're living near the polar regions, it's the worst. But it's the entire world. Eye damage, blind rabbits and salmon, Chile. Children were really getting burned during recess. Okay, people started wearing in the southernmost nations of the world long sleeve shirts all year. I don't care what the weather is. Sunglasses for everybody. On beaches, lifeguards would walk around with a tank on their back to spray you with suntan lotion so you would do it safely. And it affects the entire food chain, all right? Because it breaks down the immune system, destroys life, all right? Not just humans, entire food chain from tiny phytoplankton to shrimp called krill. Who eats that but whales? And of course all the way up to penguins. And it's the dynamics. The Earth is spinning and this stuff is shifting and changing all over. So the CFCs, we quit. Now they're there. Okay? And here shows different kinds of CFCs. This one's coming down very fast. It's breaking down. This one's coming down. These are staying up there, but they're more or less plateaus. CFC 11, CFC, not sure which one that is. So it's there. The Earth is like a bathtub there. 2008, we're really getting close. It's huge. Look at 2008. I'm going to show you 2008, 9, and 11 real quick. In the winter, darkness, no sunlight. Sunlight now coming up. Starts eroding the CFCs, chlorine's escaping, grabbing onto the ozone, and now the UV comes through. Wow. And look at the blue all over the world. Here's 2009. During the winter, 6 months of darkness, no ozone hole. No ozone hole in the winter of darkness. Now, there it is. Look at the size of this thing. Blasting into Patagonia at times. Huge. Now I'm in October. So we've gone from July 1, where there is no hope. Ooh, where are you going, George? Mary? So from 79, barely got started, to 2008 for that one. Whoa, whoa. So even after we passed, we started adding the legislature in the 90s, it's still getting bigger into 2008. Here's 2011, August 22nd, 28th. Look at that, huge. Really, really big. All right, yes?
So you were saying before that the scientists that like went there, they like got burned or they had degree demolition, right? So how are like people still going?
Really, safely. Dave Merchant takes students, they just got back, and you look at the lower half of Dave's face, it's very red, all right? And that's just the sunlight part that's hitting you, all right, the visible part. So, yeah, it's a good thing to wonder about. Protect us now for an hour, won't we? Yeah. Yeah, so there it is. There's that ridge. It's normal, but that hole sucks, man, woman. So the problem, they won't go, well, I can't see it. Look, I don't see anything. Exactly, you can't see it, all right? You get it? This is not like cloud cover. Whoa. So, different forms will last, depending what kind, from 60 to 120 years, probably till the year 2100. If we hadn't done this, we're talking about planetary suicide. So not to be confused with what appears to be a debate about global warming. This was clear, and it's not just over the polar regions. So, not a good idea. Crazy. So, the world is changing, and you are in Earth Science 105, good old Dr. A, and I know you thought about that. We love our beaches, right? We love our beaches all over the world. Let's go there.
Most of these people are exposed to an invisible health risk. Harmful
Close and
ultraviolet
close.
rays that are the primary cause of skin cancer.
Skin cancer is actually the most common cancer of all cancers in the United States.
1 in 5 Americans will develop skin cancer.
You gotta wear hats and shirts. Reason being is I've actually had skin cancer. I've already had malignant melanoma.
Ooh.
We'll see it.
There it is.
1 person dies of melanoma, the most serious type of skin cancer, every hour. Man-made chemicals have damaged the Earth's ozone layer, allowing even more ultraviolet radiation to strike us.
For someone your age, you have a little more freckling that I'd like to see. Are you wearing sun protection on your nose?
UV rays are a danger not only to our skin, but also to our eyes.
To our eyes.
UV exposure can increase your risk of going blind, as it can cause cataracts and macular degeneration. Even if we take corrective action and save the ozone layer, we'll still need protection from the sun's radiation.
The main things that we suggest are wearing a sunblock with an SPF 15 or higher,
don't fussy.
wearing protective clothing, and really using common sense
Like a hat,
and not going out of your
sunglasses.
way to get sun exposure.
There you go.
Walking across the parking lot at the market matters as much as
It's
sitting at the
cumulative.
beach.
It's never
You can
too
start
late
now.
to start protecting yourself from the sun.
Or too early. Schools around the country take advantage of the EPA's Sunwise program that teaches children
lather
about
up.
sun safety.
The cancers that we get as adults start as children.
Starting now.
Lotion on, I put my hat on, and when you come out to play on the beach, I just like sit under our umbrella that's 4 inches.
It's impossible to avoid all the UV rays that surround us, but Sunwise habits can help ensure that we'll always be able to enjoy
Put it
tomorrow's
on.
sunny day. For the Weather Channel, I'm Nick Walker.
Thanks, Nick. The stuff you can find on YouTube is fantastic. So, you know, here's all Dr. A is saying. Do it safely, all right? Cartoons. Oops, sorry, Vlad, dear. I must have missed a spot. Summer tip number 26, never use your chest as a beer can holder while suntanning. So, you know, go out there. I'm not saying don't go to the beach. I'll be out there with you. We'll have a good time. Just do it right. Not like that. Crazy, Lawford. All right. Have a good day and safe from now on out.